Hello ladies and gentlemen, my name is Brentheim, and in today's video I actually want to get you up and running with Minecraft coding, as well as I'm going to demonstrate some of the things that we can do with it. So in today's video I'm going to cover something I did in another video in a better format as far as installing Minecraft Make Code or Code Connection with Minecraft Windows 10 Edition. If you don't know what that is, it's actually located in the Windows Store, and I've already got it installed right here. And we're going to go ahead and pin that to our taskbar so we can bring it up real fast. I don't want to bring it up before we have Code Connection installed. So in a URL in the video description below, there will be this link, and you'll click it, and you'll go to this page, and you'll click Download Code Connection. If you do not already have Minecraft Windows 10 Edition, you're going to need to buy it from the Windows Store, which if you click this link, it'll take you right to it, or you can use it to actually bring open the Minecraft Store. But for this purpose, you're going to hit Download Code Connection once you have the other Minecraft installed. And this is the code connection being installed here. Just wanted to show a brief window for it. Should only take a second. Once that is installed, you'll see it up in this left-hand corner. It's a little villager-looking thing. It's technically the robot that you will be controlling. So we'll hit Allow Access from our firewall, and you'll see this /connect. And it's this is actually an IP address. If you do any networking in school, or if you've done any networking at home, this is an IP address, and this is a port. It's not really important that you know that. I'm just giving you a little tidbit of information. So once you get this open, you hit this little copy window, and once you've done that, we can now open Minecraft. Again, this is the Windows 10 edition, and we're just going to hit play. We're going to hit create new. And you don't necessarily need to do this. You should be able to use a world that's already been created. So I'm just going to call it, for this purpose, YouTube Coding. I'm going to go ahead and do survival because I don't really care. We'll add some bonus cheats. Active cheats. It doesn't matter. So once we do that, we'll hit create. It's going to start a game. Just gotta wait a moment. Now I'm keeping this windowed so that way I can hit T. I can paste. I used Control V in that case, but you should be able to, I believe you can right click, but you should just be able to hit Control V and that will paste. Okay, so yeah, we do need to enable all cheats. So let's save and quit. My bad. We're gonna edit it. Come down, activate cheats, hit continue. We now know that we will not be able to, actually I'm going to go ahead and make sure it's always day. Do know that we will not get Windows or Xbox achievements, but hey, you know what, we're coding, that's more fun anyways. Alright, again, hit T, then Control V, and paste it. This is actually going to allow our robot to join. Once our robot is joined, we can actually select an editor. I'm going to go through them real quickly, real briefly, so that you can actually see what each editor looks like, and you can kind of make decisions for yourself. So opening the code.org, you can see our workspace here. We can hit create new, or we can actually import projects. I believe with this, it's actually easier to use the web interface. I don't know if it actually connects with it, but we can go ahead and sign in. You can save projects or download projects. This is a lot easier if you're doing it with your teacher, if you're in a classroom setting, but for my preferences, I don't actually enjoy it. We'll come back to make code in a second. We can go ahead and see Scratch. If you want to use Scratch, you actually have to download it. You can see that it's actually a plugin right there. Again, we're not probably going to jump into that, so I don't actually care. So then we also have Tinkerer, which actually shows different projects the community has posted for this, which is okay. That's alright. And we can actually add a custom service to it if we want, but we don't really care. The easiest way actually is to use something called Make Code, which is introduced by Microsoft. So you can obviously see that there's a couple of tutorials if you want to learn. There's a couple of example templates, You can also see some more example templates, basically pondering on different things that you can do in the game. And then also you have videos that can range from tutorials to just straight cool things that people have made. So for our purposes, we're just going to hit new project. So you're going to be introduced into this interface here. Now what this is actually analogous to Google's blocks. Basically that means that it's programming but in block and graphical form. And then here you can actually convert it into JavaScript. If you do not know JavaScript, I recommend staying with the block form, and then once you've completed your code in the block form, switch back to JavaScript so you can start to learn kind of what you did and go through it. So let's first go ahead and see the robot that we spawned. He'll be Steve.agent, mainly because it's the name of our character, and then the agent is his name. So currently, he's not going to do anything. He's just going to kind of sit there. He is like a computer. He does things really well that we tell him to do, otherwise he does absolutely nothing. Basically a computer. So, in this purpose, I'm going to go ahead and start in the block coding style, just so you can kind of see things that happen. And you can kind of learn the block way of doing things and then kind of take it to JavaScript eventually. So let's go ahead and make the agent. So let's do, if we type in chat the phrase to me, if we type that, then the agent will teleport to the player. So let's try that. To me. You can see he actually teleported to us. So let's get really far away. And let's try it once more. Awesome. He did exactly what we expected. Now let's see what that looks like in JavaScript. So player.onChat, when I say to me, it calls a function which basically says agent.teleport to player, which is a function of the agent class. If you don't know what that means, then it's more programming jargon that you can kind of mess with. So we can actually call more player functions. So player.on traveled. So when we walk, let's actually make him teleport. Let's see what happens. So now we've actually made a follow function. So now every time I walk, he comes with me. But what happens if I jump? Now if I jump, he doesn't necessarily teleport until the first time that it gets an instance of me walking. Funny thing also, this can be considered a bug. If we want him to always follow us, what happens when we get into water, when we're not walking? We're no longer walking, he's no longer following, which in some instance, if we want him to always follow us, can be considered a bug. So how do we correct that? First, let's get back on land, where we know he'll follow us. Next, let's type player.on. Let's look for a swimming function. We'll use the same function and switch it to swim. Water. Let's gather the same phrase, or the same method of teleporting to player. And now every time we swim, he'll also follow us. We don't necessarily care about lava, because if we start to swim in lava, we're pretty much dead anyways. Alright, let's see what else we can get him to do. Player.on. Let's see, if we do... Let's do on arrow shot, and let's see what we can get him to do. He should attack. Maybe. Let's see. Agent.detect. Let's switch back to the block and see what that's... Ah, it actually discards entire blocks that we use because they're not necessarily implemented functions. Ah. So let's go into player. Let's do, so on player walk. Again, this is just the implementation of the functions we just made. Let's delete those. Let's copy and paste that, Control C, Control V. When we swim in water, Control C, Control V. When we fly, it's probably a good idea. Let's just be crazy with this. When we're riding. When we sprint. Ah, interesting. So originally when I was playing with this, they actually didn't have most of these functions. So now, one of the things that we were having a bug with earlier when we were bouncing was that. So now when the player is bouncing, that also happens. Also when we fall, and we can do when we climb. So let's throw all these functions up here and kind of get them out of our way because they all do the same thing. And we'll keep them up there. Not necessarily the most organized, but I don't actually care at this time. So now let's do on arrow shot. Let's find out what he can do. He can detect a block or redstone. Let's not really care about that. Alright, I don't really see anything we necessarily want him to do when we shoot an arrow. Maybe destroy forward. That depends on the direction he's facing. That doesn't necessarily do exactly what we want. So, let's see if something we can do with a mob. So how about we do player, on arrow shot, we'll spawn an animal. Let's pick a parrot when we shoot an arrow. We should be able to actually replace that little thing there. And we should be able to get like player position or something. Player world position right there. So now, when we shoot an arrow, we'll spawn a parrot. So let's actually go ahead and try that. Interesting. Alright, sweet. Now we're in creative. I just did /game mode 1 for that, by the way. And let's get an arrow. And let's get a bow. Now that we have that, we can go ahead and shoot it. And as you can see, we're spawning parrots now. Because why the heck not? Alright, let's try something else. Why not? So you can see that, let me kind of explain this for a second. So these statements that have basically an alligator or dinosaur looked in my eyes, they're considered conditional statements. So when something happens, do the thing that's inside of them. In programming, if we switch to that, they're actually basically considered event handlers. If you don't care what that means, just ignore it. But basically an event handler is similar to what we use in graphical user interfaces like Windows. So, on this statement, when it happens, do what's contained. So let's see what something else we may be able to do. We can also actually do a loop, which is quite fun. We can do some math, which if you don't like math, then that's always a great little time. So let's actually some logic with comparison. Here's actually a conditional. Can we get player direction? No, not necessarily. We can call projectiles. Maybe on player arrow shot. It doesn't necessarily let us do that. Interesting. Keep looking. You can actually pick random positions, which is kind of neat. Add time. Change mode to survival. Change game rule to PvP. Maybe do some blocks. Yeah, let's get the agent to build something. Why not? So let's build a loop. Let's do 4 index from 0 to 10 till forward. Once he's done that, we'll do another for statement. That's a forever statement. My mistake. 4. So once he's tilled forward, we're gonna do for an index of 5. Not 45. Once he's tilled forward, let's till to the right for 5. And once he's done that, he needs to rotate. He may need to rotate. Can I rotate his position? There we go. Turn. So once we've turned to the right, we'll turn right again. He'll go forward another 10 if I do a loop. And we'll do this whole thing. Let's try twice. This should probably make a square. And then we'll do that on chat command farm please. Alright, let's try that. So let's get to a spot that seems pretty okay for a farm. Maybe it's a good idea to fly. Again, he'll follow us, as we set that conditional earlier. Event handler, if you want to call it that. Alright, I see a pretty flat piece of land up here. This should be ideal for what we're trying to do. You should only do it for about 10 by 5, or, yeah, it should be a 10 by 5 square plot. So it shouldn't be enormous, but it's going to be rather large. Okay, let's see if this works. Farm, please. Because he teleports, it gets a little weird. See? Now we created a bug, because I'm an idiot. So right now, he's just turning consistently. What we actually need him to do is at the end of this loop turn, but we also need him to move forward every time he does it, which is definitely an issue. So we'll have him move forward there, and we'll have him move forward there. We should probably also till forward, but turn him to the right. Actually, this may not do what we need to do. Screw it, though. Let's see what happens. Yeah, he's gonna, oh, well. I don't know why he's going the direction he is. Let's try this again. Actions almost seem sporadic. 3, 4, 5. Interesting. So he actually goes in that line. So this is the part of debugging and figuring out why we have an issue. And that's what we call it in programming. Um, Part of the reason is we're actually moving him forward every time. Or not moving him, turning him every time we do this, which isn't necessarily the correct way to do it. So let's actually take that out and see if that helps us. Alright, let's look for a flatter piece of land. This is maybe a little too tight. Don't worry, we'll find something. As you can see though, coding isn't necessarily hard, but it actually is fun and rewarding. Once you get something to do exactly what you want, it's probably one of the better feelings that I've come to know. Alright, this is perfect though. This is exactly what we want. Alright. Farm, please. Maybe it'd be best if we moved way out here. We gotta bear in mind that the direction he's facing actually does matter. I'm not entirely sure why he keeps teleporting back and forth right there. There's our parrot, by the way. So actually, one problem I can see is that we actually move him before we have him till, which is actually an issue. And he doesn't work inward, he just creates a square around, which isn't actually what we want. So we actually want him to till, let's say, till forward 5. Then he should turn 1. Should turn to the right. And then he should move forward 1. We may not necessarily need this second for statement. So, let's do it for 10 times. So he's gonna he's going to move forward. Then he's going to, he's gonna tilt forward. Then he's gonna move. Then he's gonna turn to the right. That's not good. That's not what we want. We actually did want that for statement in there. So then he's going to turn to the... That's for the... we don't want that until the iteration is done. So let's move this out. And move it above that. So once the iteration is done, we want him to do that. So... Okay, that's probably about right. So then he'll... So he'll tilt forward, then he'll move. Then he'll tilt forward. Maybe we may not even actually need that and that. So he's going to tilt forward, then he's going to move, then he's going to turn right. No, actually, again, those two were just copy pasta. We didn't need that. So he'll tilt forward, move forward, tilt forward, move forward, tilt forward, move forward. Then he'll turn right. Then he's going to move forward 1. But then what we also need to do is have him actually turn again. And we'll have him turn right, which will make him face the other way. And he'll do that 10 times. Let's see if this is it. This very well might be it. We might have just solved it. Ah, he's going in a circle still. Interesting, because he turns right and he comes back around. That makes sense. Okay. Which means that we should change direction. Weird. At that point, he needs to turn left. So maybe he does that twice. And then we take this. And he turns left. Then he moves forward. And then he turns left again. Let's try this. Why not? Can't hurt. A little bit of debugging. 4, 5. I'm not sure why he goes forward 6 times. No, I guess, yeah, 2, though. Because we haven't done it twice, which means we probably should only do it once. Okay, alright. Alright, let's try that again. This is actually 3 nested loops, which actually isn't very efficient. But it's getting our job done. Why does he turn right there? Confusing. He should have actually turned left, but he didn't. I'm not entirely sure why. We can actually probably do this in the air and see most of the same results. So now he's coming down the back lane. And now I would want him to turn left. But he turns right, and then goes right, and then goes... What? I don't understand. Why would he do that? So he should turn... Right. So he's gonna do that. So he'll do that once, then he'll turn right, do all that. Turns to the right once he gets up there. Right? Or am I wrong? Well, clearly I'm wrong. He does the whole right thing once with moving, which is good. That's what we want. And then he should turn the left the next time. But he doesn't. Actually, let's see when he turns left. So he's gonna move forward. Well, let's make him move forward 5 times. So this'll be a little debugging, and we'll really see when he's turning left, which is good. I mean, that's, you know, obviously the point of this. So that's where he's turning right. So we know. Oh, whoops. So we know he's right here right now. Oh, he's right there, and then he's turning left right there. Wait a second. So when he turns right, we finish the loop, which means this doesn't run again, which is not how we want it. So we actually may want this again. Maybe that'll fix it. Farm, please. Oh, I don't actually... We didn't even finish... That's not even spelled right. Yeah, let's move him. We can probably come down to this flat area and see what happens again. Hopefully he stops farming. I'm actually going to change this to 3. Ah, stop farming, stupid! Alright, let's try this. Oh, duh. So now he goes... That's not confusing. Why did he run that again? This still never got run. Oh, whoops. That should... Well, ladies and gentlemen, I'm going to have to solve that a different time. If you guys want another video of this, if you want to learn more about coding, go ahead and leave a comment in the comment section below. I will 100% look at it. I appreciate you watching the video, and if you haven't seen any of my other videos, please do have a look at the channel, and please consider subscribing. If you like the video, like it. If you dislike it, go ahead and dislike it. Ladies and gentlemen, this has been Brent Time. I'll see you in the next one.